So I want to make sure that you understood one thing, that in this entire problem, when we were working it out, I have dropped the k because it is essentially was not responsible for any calculation, which I shouldn't have done. It should have this k all over. So that's the only thing I would suggest. So should be a k there every time you have this k. It's just a constant, but I cannot just ignore this constant. It should be present in the entire problem. So we will put the k in, and I just realized when I was fixing the k constant that I made one more mistake while we were writing the formula, transformation formula. I said phi is equal to arctangent of z over r. That should not be the right thing. So in fact, I'm pretty sure you guys were thinking that that should not be the right thing. It should be arc cosine z over r. So that's what it was. And so let's go ahead and start working on the next problem. So this problem is asking us, use the spherical coordinates to find the volume of the solid. And the solid is inside the sphere x squared plus y squared plus z squared equal to 36. Outside z equal to square root of x squared plus y squared. So what I'm trying to get into this problem is, what is the situation that we will be playing with pictorially. So first think about the sphere of radius 6 units. So this is the sphere of radius 6 units. And we have this is as the outside boundary, and the inside boundary is the cone z equal to square root of x squared plus y squared. So that's this picture. And we have our three-dimensional object bounded by this outside and inside. So what we are first trying to understand is, what are the limits? So first and foremost, think about your r variable, rho variable. Rho is pretty easy to understand. And it is just varying between the center of the sphere to the boundary of the sphere. So I'll go ahead and say that 0 less equal to rho less equal to the radius of the sphere, which is 6 units. The interesting information is the information for finding phi. Phi is the angle between xi cap plus yj cap, making an angle with the z-axis. So that's what we are trying to find out. How do I find this out? Well, first and foremost, we know how much is this point. So what I do, this is the point of intersection of this cone and the sphere. So look at the cone. The cone is z equal to square root of x squared plus y squared. So square both sides, you get z squared equal to x squared plus y squared. Okay, so if it is z squared equal to x squared plus y squared, then I will go ahead and say, using information, this information in the sphere, I will get z squared plus z squared equal to 36. So 2z squared is equal to 18. That means z squared is equal to 9. So absolute value of z is actually 2z squared is 36, so z squared is 18, and so absolute value of z is square root of 18, which is 3 square root of 2. So we'll keep that value, 3 square root of 2. Which one I take? Well, at this point your z is greater than 0, so you take the positive value and you say z is equal to 3 square root of 2. What else? Well, remember, now we are going to think about phi equal to arctangent of z over r. So your z is actually z over rho. So let me go ahead and fix it. So z is equal to 3 over square root of, again I said arctangent, should be arc cosine. So it is arc cosine of z over rho, which is arc cosine of 3 square root of 2 over 6 units. So what I get? I get arc cosine of square root of 2 over 2, which is pi over 4. So you start at pi over 4. This is phi pi over 4. This one I do not have to do any work. This is pi over 2. So I go ahead and say that phi is in between 0 and pi over 2. Finally, I'm going to talk about theta. And theta is on the xy plane. It is a total circular measure, and that's between 0 to 2 pi. So you will go ahead and say 0, that's equal to theta between 2 pi. So we have found all the limits. What else? We're going to write down the form of the integration, which is going to find the volume. So volume is going to be Let's do 0 to 2 pi. So integration with respect to theta at the very end. Then, as I said, it's pi over 4 to pi over 2. That's the limit for phi. And then finally, 0 to 6 is the limit for rho. And then remember, I always need rho square sine phi. That is the term that I get from the Jacobian in the spherical coordinate system. And then I do d rho, d phi, d theta. That's my order of integration. So let's go ahead and do it. I'm going to first integrate with respect to rho. So that'll be rho cubed over 3. So 0 to 2 pi, pi over 4 to pi over 2, rho cubed over 3, limits are 0 to 6, and I have a sine phi, d theta. Okay. So I'm going to put the value 6 in there. 6 to the power 3 is going to be 216, and when I divide 216 by 3, I get 72. So this entire thing is a constant. You can take it out. 0 to 2 pi, integration pi over 4 to pi over 2, and I just have sine phi, d theta. So when I do the entire derivative, I get minus cosine of phi, entire derivative 0 to 2 pi, and the limits for this one is pi over 4 to pi over 2 d theta. So let's put the limits in, and again I'm just going to get constants. So minus 72 times the constants for, if you put pi over 2, cosine pi over 2 is actually 0, minus cosine of pi over 4 is square root of 2 over 2. Integration 0 to 2 pi, and you are integrating d theta. So what I get 36 square root of 2, and integration d theta is theta, 0 to 2 pi, so I'm going to get to multiply 2 pi with this. So 36 square root of 2 times 2 pi, which is going to be 72 square root of 2 pi, and that will be the required volume. 72 times square root of 2 pi. So that precisely takes care of the answer in this problem.